Short introduction I have already given the students. I have PhD in 2011 in University of Allahabad and work done with the IIT BHU with Professor B. R. Vishkarma. And during that time, I have worked in antenna designs. So I have already done some antennas, which is useful now in the market. It's like half circle antennas. So they are in the market in China as well as in India. So there have 5 patents in antennas. And after that, based on that works, one of the great professor in antenna design from Nanjing University in China, which is the top 10 university in China, they offered to me as a postdoc scholar. So I back to China in 2013. I joined as a postdoc scholar, and during the postdoc scholars, I done some multi-band antennas, which is useful in the Chinese market. Now they have some patent and some special project funds there. And after I finished the postdoc, they already offered me as a post associate professor there. So I already joined there in 2018 as a associate professor in same university, Nanjing University. And during that teaching tenure, I published some good SCI papers, either like a Nature and something. And I got the good research fund in international fund. It's near about 3 crores Indian currencies. So they offered me to as a professor, full professor. So after 1 year, they given me the full professor there. So I am working the full professor since 2018, September 2018. From that time to now, as working the full professor. And during that time, I worked a lot of research fields, and I make the big research teams, especially for the young students. Most of the students from China, and maybe 30% students from India, and some students from Pakistan as well, and some students from European countries. So there are overall 50 students group, and 10 teachers in my group. We have the collaboration in some good universities like Glasgow University in UK, and HENU University in USA, and IIT Kanpur, Vaibhav Srivastav, and Gangwar sir, ISM Ahmedabad, and IIT Delhi, Aswani sir, and a lot of professors in India, especially IIT, and ISRO Ahmedabad. So we have the big collaborative teams. We are working especially for the antenna design, microwave as well as in terahertz. So most of the antenna has already application in the 5G application. Now we are working for the 6th generation, 6G. 6G is working in China. It's not more, but in the beginning, they start the work in the 6G. So in the beginning, they face some problems, especially the human life. So we have the challenges to how to solve these problems by using the technologies. Because the coming days, the technology is coming, a lot of technology, especially the AI. How we can save the human life with the from AI and the 6G. So due to these challenges, we are working in the terahertz. So in terahertz, a lot of work we have done, but especially in your programs, we are showing how we can show the terahertz in 6G, especially for the imaging. And the nanotechnology, how can enter in the terahertz, and how we can design the waveguide model, some antenna model, which can help in terahertz, and how we can work with the AI, with the machine learning. So these main key points I will discuss in my talk. So this is my introductions and my plan. So now the focus on the topics. waveguide antenna-based terahertz super resolution imaging for biomedical application. Biomedical application, basically we are applying in the medical science. Most of the terahertz antennas we are using in the medical science. So three. Now they start some in about the China. This is our student teams when they are graduated from my research group. They are enjoying as a like a graduate. When they will graduate, they will find a job very easily. In China, it's very easy to find the job after graduation. It means after BTech. But their BTech is very difficult, not so easy. It's like India. India, if you're doing the BTech, there are some procedure like you can write some thesis, and after the defense, you can find your graduate. But there, the difference is that you have to make the model design. You have to be make the model, some device based on your thesis. If you successfully to make the device, then you will be graduate. If you're not successful, the 6 months will be extended. So that is a very difficult for the BTech student in last year. So all the students, they are working, how will we make the device in the first year? They are thinking, how will we make the device? So this is the big challenge there. So they are very happy because they are already graduate from that university. In our university, about the 18,000 students, 18,000 students is BTech, MTech, HD, and some medical students, and a lot of departments there, and about 15 young professors from different countries. They are doing the research in different majors. And in China, if you look at any university, they looking very beautiful. Especially if you look at university from the upside, it's all around there have the lakes. So my university basically around all sides is very good lakes there. And they have atmosphere and weather is very nice. It's 12 months. Every month you feel about 15 to 20 temperatures there. It's not so hot, not so cold. It's cold. In the cold time, it will be some cold. It's around -5, -6. It's only 1 or 2 months. So there have some snowfall or something there. But overall, the weather is very nice. Now I start the talks. I already discussed about the terahertz. I will give some talk about the terahertz. When you start the work in any research major or any device, you have to some challenges. So the challenge has made to make the terahertz device small and powerful enough. However, the recent advancement like those from the GCAN Center from Advanced Photonics is all collaborative center in USA have made significant progress in creating compact and strong terahertz wave source. Now the terahertz source only making in the USA. So our research collaborator, they are making the terahertz source. This brings us closer to using terahertz technology in practical application that benefits our daily life. A general method that extends respective deep neutral network from terahertz spectrum to visible wavelength will be discussed. I will discuss about the how we can use the deep learning. An improved formula is proposed to solve contradiction between wavelength, neuron size, and fabrication limitation. The diffractive deep neural networks at visible wavelength can implement covered and alter target classification. Waveguide, AI, and nanotechnology. There are three things plays a crucial role in the development of terahertz technology. By manipulating the engineering materials at the nanoscale, researchers can enhance the properties of terahertz device. So we are focused how to make a terahertz device by using some model in the terahertz source and the camera. So what things we can apply? There have the challenges. Nanomaterials such as nanoparticles and nanowires offer unique electrical and optical properties that can be harnessed for the efficient terahertz generation, detection, and manipulation. We propose some latest application of nanotechnology to improve terahertz biological detection capability for providing progressive terahertz system, thus enabling outstanding detection of performance using terahertz spectroscopy and imaging. This will encourage broader interest in various fields. The unique limitation and process of terahertz biological application based on nanomaterials and nanostructure will be also discussed in the light of recent developments. So we will also discuss some optical fields there. Why I choose the biomedical imaging? There have some question. Why you use the terahertz in the biomedical imaging? So there have some question. Why terahertz? Why terahertz using? Because the non-ionizing spectroscopy, fingerprinting, water sensitivity. This is the advantage. That's why we use the terahertz. Challenge. What is the main challenge? Diffraction limit. This is the big challenge of how to break the diffraction limit. It's not only terahertz, as well as microwave and optical system. So in microwave, we have already made many things to break the diffraction limit. But the terahertz, the wavelength is very high. So how to break the diffraction limit? This is the big challenge nowadays. But we are working nanotechnology and AI, machine learning, neural network that can help to break the diffraction limit. If we are successful to break the diffraction limit, anything can possible by terahertz. Waveguide antennas. This is also good measure. Waveguide antennas, there have two types of waveguide antennas. We can use that antenna to make this antenna and join with the terahertz source. That can be helped to break the diffraction limit. So this is some challenges and some introduction of why I use the biomedical imaging. And there are some technical challenges. We have to face these problems. We are working, there are some parts. Now, if you use the terahertz biomedical application, there have two parts. Terahertz biological effect and terahertz imaging. Like in the human body, if you scan the human body, there have some big tissues and a small tissues. So how you can find the big tissues or small tissues? Like DNA protein. If you want to scan this part, it's very difficult by terahertz because the size is very small. In visible, you can easily, but terahertz is little difficult. So we are working on this. How to scan the DNA. If we succeed the scan the DNA, it's very popular in medical science. Because in medical science, if you check the DNA, a lot of devices, but in the terahertz, if the terahertz provides this thing, it will be very useful. Hydrogen bonds, cancer cell, brain tissue, blood, fat, all this, if you scan the human body by terahertz device, it will be very useful in medical science. So we are scanning all these things. We are scanning. Last year, we have successfully scanned the cancer cell by using the terahertz device. This is some application background. It's like a human scan, bioimaging, medical diagnosis, and some industrial applications. I will show some application one by one. Why I choose the waveguide? Advantage, what is the advantage? Beam confidence and SNR improvement. Need for super resolution. This is the big challenges of super resolution. And what the difficulty? Diffraction limit. If you broke the diffraction limit, then we can find the super resolution. Physics of waveguide. What is the physics of waveguide? Surface and plasmonis, SPPS. We have to work on this. And practical challenge, water absorption. This is a practical challenge. Computational method is SR processing. Now I going to start what we have done and what we are working in the terahertz. Like in these pictures, we have making the chips is like a terahertz, and that can be scanned is a very small size, even in a micro size, because the wavelength of the terahertz is a 1 meter, 1 millimeters. But if you scan that is micro size, it means you have to make the something in the device. We have already done it. This is some optical things. It will be like photoconductivity image sensors. Now the terahertz antenna. This is very useful for you young students. You have to think about like polymeride gold. Gold is little not comfortable, so you can think about what we can change there. And this is very simple model like microstrip patch antenna. This is basically the waveguide, but we have to model make in microstrip patch antenna. So you have to think about all your others design and look the results. The range is very high. Is near about 500 gigahertz, 600 gigahertz, 700 gigahertz, and there have good bands there. Bandwidth and gain efficiency is everything is very fine. So problem is that how we can do the experiment of this device. This device, you can do the experiment. We have already in the lab, there I have some terahertz experimental lab. You can do their experiment. And all this, the sensor model, there are a lot of sensor model. We can working on the photonic sensor, thermal sensor, field sensor, and photoconductive sensor, electro-optic sensor. So how we can work this sensor in the terahertz? Like this. In my laboratories, if you look, there have the tera sense source, and one is the terahertz camera. The terahertz source, where you can apply the waveguide in this near to terahertz source. We can make the model of the waveguide and we can join in with the terahertz source. And that can help to the scanning of the body or scanning of the materials or the scanning of the any industries samples. And this is the terahertz time domain model. We have already used these things for the different mirrors and some specific arrangement. In this setup, till what frequency we are able to measure? Is terahertz. Yeah. Is until now we are measuring about 800 gigahertz. 0.8 terahertz. Yeah, in terahertz. Yeah, in gigahertz about 800. So that's why we can use in 6G, because the 5G has a limitation. So in the 6G, if you have the research frequency band high, that can be used in 6G. It's very easily, and that can be entered in the imaging field. When I am doing the postdoc in Nanjing University, I have developed this device. His name is like a PME. He can name is PME. Means parametric indirect microscopic image. If you visit in the hospital or any laboratories, you have to look only the microscope. But this is the microscope, but it's a special microscope. If you read the physics of the microscope, you can find the resolution of the visible light of 532 nanometer, 532 nanometers. But when I made this microscope by using the polarization concept, and we got the resolution about 50 nanometer. 50 nanometer. This is very good achievement, because if you use the electronic microscope like SCM, AFM, TEM, that can be measured about 1 nanometer, even less than 1 nanometer. But that was the electronic microscope, and this is the optical microscope. Optical microscope, no need any electronic sense. It's very cheap compared to the electronic microscope. If you look any universities, very less university have the SCM or AFM or TM. You cannot afford. But this microscope, if you want to use for the research or if you use the scanning, it can be buy very easily. And that device can be used in the medical science as well as industrial application. Like chip, if you want to look the semiconductor chip, how to scan the semiconductor chip or some default, that can be useful. And we have used some deep learning model. Deep learning model. We are working also deep learning model. We are also looking some young student who working in the from India, especially IIT, who know the deep learning like machine learning, data analysis, and some AI. They are welcome to our group, because in my group there are few students of deep learning. We are looking and hire this. We have measured some animals samples there about the terahertz. If you look the rat there have some problems in the rat, so you can find the problems, where is the problem there. This is the waveguide. If you design the antenna, so you have to prefer the waveguide. Waveguide model will be different. You can think about which model will be more useful and more effective in the sense of resolution, in the sense of useful in the terahertz. If you use the waveguide in concept of microwave, it can be used the result in only maybe 10 gigahertz or 15 gigahertz range. But if you use the waveguide in sense of terahertz, your target should be at least 500 gigahertz. 500 gigahertz. And how it can be possible? First, you go to the simulation. Simulation, you can use any software. We are basically using the console. If you use the console, there have some good procedure to apply the waveguide model. And you have to be the good computers. It's low RAM, it cannot possible. It will take a long time. So you have to big computer station, and you have to make some, first you have to make some design, and then you start the input. And after 4 or 5 hours, you think and look your results. If your results is not successful, you have to apply again. It's like cut and try method. So the young students, you have to try to the waveguide antenna, not like the microwave. You have to think about in terahertz. Then it can be internet 60. Like here, the waveguide 1 and waveguide 2. Waveguide 1, waveguide 2. You have to design two models, not the one waveguide. Maybe the waveguide 1 is useful for the source, and waveguide 2 useful for the camera. So they have a terahertz detector and terahertz source. I have already buy this terahertz source from USA company. It's about, if you think about Indian currency, it's about 2 crores. It's very expensive. Looking very small, but very expensive. Why expensive? Because they are making the spectrum. They make some spectrum, we can make it. Especially the Indian can make it. They have the good software skill. They can make it. ISRO Ahmedabad, they have already successfully done it in 2021. And they have applied in the space. The terahertz can be useful for the space science. Microwave can use in the radar and something. And that can be also used in radar. But if you always use in the good way in the use for the space science, the terahertz model is very useful. So I just tell one short story about the ISRO Ahmedabad. When I give it the talk there, because the ISRO Ahmedabad is a government organization from the Defense Ministry. And that time I was belong to the Chinese government university. When I enter there and give the talk, so they have given to the one application. There have some security between China and India. So we have to not disclose some secure things in Indian talk. The Chinese government asked me, they given me the forms and I need to sign there. And then I approve the talk from ISRO Ahmedabad. And what is the differences there? They using the terahertz model in space science. And I was using the terahertz model in imaging science, in medical science. That's why they allowed to me. If I use the terahertz model in the defense, then they cannot allow, because this is the defense project. So this is not where we can talk there, but there have some good students there in ISRO Ahmedabad. They want to know how you can implement this device in the medical science. So I have given some ideas there. They implement it and they make it and they successfully done it. So from that time, I know the Indian people can do it. I hope some young student can do it, because they have the good software skill. The Chinese student, they haven't the software skill. They only make it the hardware very quick. They can make the program very quick, but try to the copy and paste sometimes. They don't want to use mind. This is some little drawback. So this is the model. Waveguide 1, waveguide 2, you have to think about, this is your target in your postdoc. Okay? If any student will come to my research group as a postdoc, the first task I will give you to make the waveguide model. Waveguide model, I can give you the design. You have to simulation in console and show me the results. And you have to know the CST, HFSS, and some other software. And you have to very good in the MATLAB and how to make the programming. If you put some data of microstrip patch antennas coding, you have to code very quick and get the output. Okay, this is the main task. And after that, there have something to like camera, terahertz detector. Recently, we are making it, terahertz detector in my research lab. We are making the new terahertz detector. Last time, the first time I have buy from the Russia, but now we are already making our research team, because in detector need only the materials. So we semiconductors, chip and some materials. So we are also working in the material science. There are some students, they are working in material science, like DFT. If you know the DFT, it can be very easily to synthesize the materials and implement in the terahertz science, terahertz technology. This is the results. The size of the sample is 1 millimeters. And if you go to the resolution point, look there, the resolution is very good. So who can do it? Terahertz, based on the waveguides and some special changes. This is the console result. Look there, without waveguide, without structure, how the results there. And with the waveguide. So when you start make the waveguide, go to the simulation, you have to got the results like that. If results will come like that, we will implement in the experimental procedure. Then we will go to the implementation of the experiment in the fabrication. And after fabrication, we will put in the terahertz source. So there have some procedure step by step. The student will do only the simulation. We will do the experimental. And if everything will be finished, the student will write the papers. We will help there to how you can write the good knowledge, good thing in the paper. Then can be challenges to the high level journal index like Nature or SCI level 1. If there have some, if at least little new things, then that can be easily acceptable. Because the terahertz, very less people doing this. What is the problem? Because due to the funding, most of the universities have no funding, use fundings. So that is the big problem. Otherwise, everyone want to do the research in the terahertz. And what is the advantage in my research? Because we have already got the international fund. It's about 40 crores. It's huge money of Indian currency. Is 5 years. And there have the huge option to hire the students as a postdoc, as a PhD, and some young teachers who can work in India. So it's very good option for the young students. We will always help to them. Especially I am looking the Indian people because there have if the Chinese people, there are some language issues. I know the Chinese, but sometimes the common word, like our oral words, sometimes we are very kindness in Indian people, but the Chinese people very it's like a decision making, very quick decision. If they don't want to research, no research. Indian students, if they have some problem, they will ask, today I will not, tomorrow I will read. It's okay. It's acceptable. But the Chinese student, if today is not possible, tomorrow also not possible. Even 1 month not possible. Why not possible? You cannot make the question. Because the human rights in the China is equal rights. The student's power is the same as the teacher power. There are some differences. The student can sit with me and they can talk to me. They can respect the teacher. They can respect the teacher. It's no problem. But in India, the student and teachers relation is very good. It's very cultural relation there. So that's why I especially looking the Indian student because I am the Indian. Sometimes sometimes very critical problems about the research. They cannot help, but the Indian student can help. Look the other results here. Frequency is 99 in 1 to 100 gigahertz. And bandwidth also is good. There are 2 bands. So this is the advantage of choose of the model, of the materials and model. This all results have done from my PhD student. He is working in the waveguide antenna for the super resolution imaging. He is now doing the PhD under my guidance. He has published 2 SCI good papers. And he is basically from India. And he done his master's MTech from IIT BHU. And he working very hard. And he respect to me very good. And I always help to him. So now he feel very happy in China. He also married and he enjoy with family. So it's very good for the young student. If you want to develop in your future, there is a very good chance there. And don't think about the China is bad. No, especially in academic, don't think about China is bad. In academic, China is very powerful, better than USA. Because in academic, they have given me full power. If the China is bad, why they given me the full power? Cannot possible. They given me full powers. You can hire the Indian student. You can invite the Indian good professor. So in academic, there have no problem. They are very good friendly between India and China. They always want to the Indian people. Even there are many Pakistani students. They don't like. They don't like the Pakistani student. Sometimes they are cheating, and sometimes due to the media influence. So they don't like the Pakistani student. They have the good knowledge as compared to the Indian student also. But due to the media influence and some problem like recently coming in the some short videos and making the medias. So they are just afraid about this thing. So a lot of students doing business in this. So this is a not good way, because in defense project you have to very careful. If something goes in the media, it will be create the problem the research group. So some of the Pakistan student can do it, but Indian student cannot, because they are follow the teacher's rules. Look this model. Without metamaterial structure and with meta waveguide. What is the difference? Very clear.
Are we trying to make this meta waveguide, metamaterial in the
meta waveguide? Meta waveguide.
It is for focusing kind of lens and things.
Yeah, this can be used like this is the source, terahertz source. So there have some point. So we can use the waveguide there. So that waveguide just collect the waves, like the terahertz wave coming there, and then that wave is scattered in different direction. So how to collect all the wave in the same place, one place? So who can do only waveguide? And in the waveguide, only the meta waveguide.
Meta waveguide that in the second case, that is after the
Without
imaging sample.
Yeah.
Instead of without wave. If we use the meta waveguide, then I think the resolution may be better.
Yes. With a meta waveguide.
Yeah, with meta waveguide.
Yeah, without meta waveguide, the resolution will be low. And with meta waveguide, the resolution will be high. This is our challenge. This is our work. So that's why we can use the meta waveguide.
If we use the meta waveguide on both the directions at the time.
Yeah, you are right. You're right. You're right. But we are only just in here. We are just checking without and with. If we use both sides, that will be more better. And even this is the student work. they can cut and try method. Like they can use both sides meta waveguide, or they can use one side other material and other side other material, and you can change the design one side other and other side. So it's based on the cut and try method. Same like the microstrip patch antenna. In the terahertz antenna and the microstrip patch antenna, is no more difference, just only difference of the frequency range and application background. Most of the microstrip patch antenna can work in 5G, and the terahertz antenna can work in the 6G. Even coming the 7G, 8G, it can be, because there have no limit of the application. But the challenges is develop the terahertz layer. This is the big challenge. So all this terahertz model, this is the principle. A terahertz meta waveguide and its imaging system is demonstrated. The high quality terahertz image are required and the resolution reach 1/3 of the wavelength at 0.1 terahertz. This imaging system is less no lens and will help to make full advantage of the waveguides and metamaterials, such as miniaturization, integration, controllability. All thought the resolution of the presented technology is only 1/3 of the wavelength. It cannot reach the level of terahertz near field super resolution technology. However, compared to most near field imaging, it achieves a longer object distance or super resolution imaging, allowing for imaging of thicker objects. At the same time, when the surface of the object is rough and uneven, imaging can also be performed without cooling with the object surface during the scanning. Besides, metamaterial is placed on the inner wall of the closed waveguide can achieve local field enhancement, which can effectively improve sensitivity in the specific sensing application. It provides a new idea which makes it possible to construct a simple, low-loss, high-resolution terahertz imaging system. We believe that the meta waveguide and its imaging method would serve as a promising and practical platform to advance high-performance terahertz imaging for a wide range of applications. That's why we choose this model. And near about one of the PhD scholar, he's successfully doing his finish his PhD based on this meta waveguide. This is the other things like a femtosecond pulse laser. We are also using the pulse lasers. So how it can be implemented in the terahertz? Like you can look there, the terahertz emitter and terahertz detectors. So there have some femtosecond pulse laser to make the arrangement of the mirrors and lenses. If you make some arrangement of the femtosecond pulse laser with beam splitters, that can be successfully in high resolution, and it can be made is tri antenna something like is a PSF. With the help of computational theories, we can improve the resolution by with the help of PSF. So there are some students, they are working in a time domain model. We have already the time domain terahertz model also. The time domain terahertz model is little expensive, and they need a lot of devices, not only one device, it need many devices. And time domain model, it can be useful in different applications. This is the array model, this one. Look the results there. Reconstruction image, IR image, and HR image. What is the difference there in different terahertz? This model is based on the RF, the microwave. We can also using some RF model in terahertz. The results is there. We can also make some conventional antennas. Conventional antennas, you can make it, and you can use the terahertz source by this concept, like SI lens. SI lens, you can make it or you can buy it. There are two options. Both options you can apply. If you haven't designed SI model, SI lens, you can buy it and you can put there in the model. This is another model of the waveguide. This is all working from students. So there have two students working in this field. Is a range from 0.75 to 1.1 terahertz band dielectric waveguide model that employ ultra low loss and broadband substrate less unclad waveguide and electromagnetic waveguide. Experimental validation of this model reveals superior performance in terms of loss. How can shape this loss performance? And they have used a different model, different structure like microstrip antenna structure. This is the latest model of waveguides. All this model, now the students, they are working on it. The terahertz range, especially in 1 millimeter, 1 millimeter. So we have already crossed the visible, microwave, radio, and that is in the terahertz. So in this range, we have to broke the 1 millimeter wavelengths by your concept, by different concept. So now we have achieved near about in micro resolution, but the research have no end. We have to target is nano resolution, but it is impossible. And now research, no anything is impossible. Anything can be possible. So we are also targeted our last aim in the terahertz to achieve the nano resolution. If the successful of this target is a lot of application coming terahertz. In China, we are providing near about 30 devices based on the terahertz, especially in hospitals. So our research is not only the SCI papers, not only your graduation, your PhD, or your master studies. That should be useful for the human life, like the industry application. If you supply your device, all the people using, if the device is useful, it means your life is useful. It means your research is useful. So we are working based on this concept. So nowadays 30 devices we are supplying in China and other countries also, even in India. Last slide I saw the microscope. That microscope we have already supplied near about 50 microscope in India in different universities. Is about 8 lakh, not more expensive. Is Indian currency 8 lakh. So most of the hospital and the university they can afford it. And what is the advantage? the main advantage is that the master program, especially the MTech students and the BTech students, if they want to finish his undergraduate program, undergraduate thesis, they should be do the experiment on the microscope, and especially in the optical field, not in pure in microwave. In optical field, they can choose to make the lens or make the filters or make the beam splitters or make some program in polarization or make some concept in the resolution. So that all these topics the student can choose and do with the device, and that is useful in academic. And in medical science, if they want to scan the body, if they want to scan some devices like diseases like size, that microscope can be useful. And a semiconductor industry also, if they want to scan the chip or semiconductor wire or something, they can scan this thing, where the especially in the edge, like this is the chip. If in the edge have the problem, like the finger, or there have some defect, that microscope can help to find the defect. So there are many advantages there. Now I entering the medical science. There have some project we have already doing and something have done in the medical science. In the last few years, nanotechnology, how we can do and how we are working in nanotechnology, has attracted attention to add the terahertz medical imaging, and various nanoparticles have been investigated as concept enhancement to improve the accuracy, sensitivity, and specificity of terahertz image. Like this project we are working on it is diabetes, how we can measure the diabetes by this terahertz device. You can very easily compare this control ABC. There have the diabetes result and without this result, and can be easily find out the result. And this experiment, we have applied the nanotechnology. In especially nanotechnology, there lot of physics there. Most of the students here, the microwave in electronics communication, maybe it's very difficult to understand. But if you have studied the physics, you can easily understand. Physics, everyone studies. So in the physics have the DFT is there to procedure of the software who can implement, who can synthesize the molecule. There have some molecules, so they can synthesize the molecules and implement in the terahertz. So there have some chemistry also, and some biology, and some physics. Join all the three majors and obtain the nanotechnology. So I especially suggest the young teachers research group not only hire the electronics staff, should be hired all the majors together. That is the advantage of the new thinking, new ideas. In my research group, there are 5 members from computer science, and electronics communication, there are many members, many students, and 5 members from the chemistry, and 3 members from the physics, and 3 members from mechanical engineering, and 2 experts from AI. So we are hiring all the majors. So if we are going the meeting in one time, we are asking the question of the expert, what should be there, what should be new in this field. So they given the ideas. So especially in the Indian, I given some time talk in the Indian University. I given this suggestion to everyone, because in China all the research team, all the big team, they follow these rules. Should be hire all the research major. It's like all majors should be belong to science and technology, not the history or something. Science and technology. Science and technology should be chemistry, physics, mechanical science, computer science, AI, electronics communication. All this major will become. So if all staff should be different measures. They can explain, they can give the ideas to make something new. Like this model, either made in the human detection, this one. This is. So the skin sample, we have already measured this. Look the differences. What is the difference in ABC? Refractive index, visual image of hypertrophic scar 6. Injury, without injury and injury. What is the difference? There are some mathematical computational we have applied in the devices and make the program and find the results. We have especially software which have make the programming. We have already done some program and make the software, and that software can find the results like this. This all the medical science. In industry application, we can also use the terahertz. Like if you want to defect some, if you want to scan some, there have the web guide, right? We can find the defect, where is the defect. And there are some mathematical formula there. This is the formula and equation. There are two students, they are working on this measure. See the defects. Is nanotechnology. How you can join the nanotechnology in the terahertz source. This is a little new. It's a new thing, but we are trying to be very close because I am not more familiar in the chemistry. So we are hiring some chemistry student also who can know the XRD synthesis, and they can do some SCM. They can make the SCM and AFM, and that can be implemented in terahertz. This can be also possible in our research group.
Slide, the graphene material is mentioned. So in your lab, is it possible to do the graphene as a thin layer over the antenna? Is it possible to deposit?
Graphene, yes. Yeah. Graphene actually very famous thing. Some students have already done with the help of graphene. And
deposition is possible on
deposition actually in our research lab is not possible. There are some connective lab in our material science lab, so they can work there. Because in our research lab, basically all the devices, computer science, electronics and electrical and electronics devices, terahertz devices. Some devices is not in our lab. So in our universities have many departments. So the student, we can sign the application, they can go to the other department, they can do the experiment there. So it's not the problem there. In China, if you want to do the experiment, it's no any problem. Just you need to journey. Like if you want to the high level of research, high experiment, you can go to the big institute, big higher university. It's not available there. So it's not a big problem. Like the cancer cell, how the terahertz can be do it. you have to apply the nanotechnology, nanoparticles, because the cancer cell is a nanoparticle, very small. So you have to make the devices of the terahertz who can scan the nanoparticle. So we are already working on this by SPPS. We have already given some tasks to the students. They are also working in the SPPS in the terahertz. SNOM is also very useful method in the imaging system. In our university have the TerraSense semiconductor fabrication lab. In the terahertz, there have some devices. If you want to make the devices, there have the possibility to go to the fabrication lab. So how to fabrication lab, how to handle this is very, very difficult. The first time if you enter the fabrication lab, there have many procedures. You have to sign everything, then enter in the fabrication lab. If you don't know all these things, don't do anything without know. You have to ask the supervisor or you have to ask the lab staff, then you can start the work, because all the semiconductor fabrication lab is very, very expensive. If anything damaged, we have to a lot of responsibility. Sometimes we have to pay the money for the university or the research funding. So sometimes the students, they just say, no, we don't know any help, no need any help. And without any ask and go to the fabrication lab. And they start the fabrication procedure. And sometimes without know the steps, they already input the fabrication. And output what? Output is damaged. No output is damaged, no successful. So this is the big things. You have to go to the fabrication and know everything. Then you start fabrication. In fabrication, you can make it a TerraSense camera. Now, these days, we are making the TerraSense camera. And some scanning devices who can supply in the medical hospital. And some devices who can supply in the industry, in the semiconductor industry. In India, there have some company in Gujarat. We have already collaboration with the company. We supply some devices from our institute to there. So in the China, all the university has one other advantage, that no need to sign any contract with the company. You can make it in your laboratory. You can make it device in your lab, and you have to supply to the country. No any relation to the company or something. You can make it yourself, everything. Like I can make the device. I can open the company there. It's on behalf of me. Government cannot stop this. Government can help. You have to open 5 companies. You have to open 6 companies. They have no problem. So I have already 2 companies in China. Company, it means not the powerful man. No, company belongs to your research. It means we are making the devices in your research lab, and that devices go to the company. And there have some staffs, they are arranging how to sell these devices to the other country or in China. So that's known as a company. So company is like 1 or 2 rooms there, and there are 5, 6 staff. They are arranging the device from the research lab, and they are connecting with the people who needed the devices. They ask them and collect the money and send to them. That's it. Everything we are handling. So in the research in China, this is the good things. But in India, if you have the professor, You can do only research or you can do any teaching in the research institution. Cannot open the company. But in China, you can open the company. Earn money from company, earn money from the university. Government have no problem. So in the China, this is the big advantage. It's not only teacher, all the scholars, all the students can do it. After 13 years, if the young students, after 13 years, it means after 12, senior secondary. If past senior secondary, you have to be the responsibility to earn the money. Any way you can earn the money from your knowledge, it can be allowed in China. So I just explained some social things there about the China. And after 13 years, you can earn the money from any side. And there are some rules of the marriage. Man means boy. Boy should be one house. And girls should be one car, four-wheeler car. Then you can marry. Without two things, you cannot marry. So how to buy the car? After 13 years, the girls students always thinking how to make the good device. If they successfully make the good device, they can start earn the money. And boy, when they're doing the PhD or something, graduating, they also thinking how to make the device, who can useful for the company or who can useful for the human life. Even they make the small device or something which can useful, they can earn money. Earn money by education, earn money by knowledge. That is acceptable. Earn money from other side, bad side is not acceptable. So this is the policy of the China. In India, 18 years allowed, right? After 18 years you can do, but in China after 13 years. So this is some social things there. This is the stone image. Maybe in India have or not the jade stone. Hear the name? Jade stone. Jade stone is very expensive stone, and we have measured in our lab in the terahertz device, because in jade stone, if you measure in deep side, there are the good metals. It's like diamond or something. So this stone only find in China. In one province is a Hubei province. It belongs to my province. It's near to Wuhan. So we have measured this stone, and we have already got the research fund from the governments, because we have successfully got some metals inside of the stone. So based on this discovery, based on this idea, the government give us the funds. And with help of our research, they ask me to scan all the stone in all the province. So they already find very good metals in the stone. So this is also useful, our project. This is the time domain spectrometer in laboratories. If any student want to do some research in the time domain, you can do it. This is the butterfly image. We have measured the terahertz time domain spectrometer is the butterfly image. If you go to the resolution, if the resolution is micro size, is very good resolution by terahertz time domain spectrometers. And this is the tablets by medical tablets. We have used some machine learning data analysis by terahertz. And this is the body cell by the terahertz sensor. So there have some project working on the medical science, especially for the body scanning by terahertz sensor.
Any works present for stellar sensor?
Yes, yeah, this can be. If we have some device that can supply in the medical science, that can be useful for the ultrasound. Ultrasound is like that. So if you interested to do some medical things, it's also welcome, no problem. In the medical things, just study, because I also don't know the medical, but now I know many things because I start the supervise the students for the medical research. So I know many things in the medical science. I just study graduation time my biology, but now I know many things in biology. If you want to scan the tablets, like medical tablets, we have already supplied our devices during the COVID-19. In the COVID-19, a lot of problems creating all over the world. So that time in the hospital, they given suddenly any medicine of the patient. They don't know which medicine can be useful, and doctors given any medicine. So how we can find this is a good medicine or bad medicine? We can also scan by our device. Sometimes if you go to the company, it's a chemical company. If you look the making the medicine, how they implement the procedure. Sometimes they not follow the rules. Sometimes they not follow the how many materials should be implemented in the tablets. So that things you can scan it. You can scan and find by the program, and so in the your computers. So we have already make it this device. And one other project we in our group is also working on the teeth diagnosis. In this project, the Chinese government have given me the Young Scientist Award because in medical science there have the scanning machine of the teeth diagnosis they have already, but in the terahertz it's very difficult, but we have done it, and this is the result there. In the results, we use only the polarization concept, not very other thing, just polarization concept. And that can be useful for 3D image. And you can find the defect of inside in the beginning of the problem in the teeth. Sometimes you go to the hospital, if you feel the tent in the teeth, then you to the go hospital. Even in nowadays they check your teeth and they sometimes they broke the teeth or something. But you don't do anything, don't need anything. Just scan our device and find the problems. They have already made some medicine. It's very common medicine, natural medicine, not the English medicine. Very simple, and its medicine goes right through the neurotransmitters. That's why the government give me the Young Scientist Award, because the neurotransmitter is very different thing. Nano devices, if you supply the nano medicine inside of the body, it's very difficult. So the neurotransmitter can help it. Why it can be useful? Because it cannot create the problem by other cell. He can find the target only the defected cell. Like if you want to the cancer, give the cancer cell, so that can be target in the cancer and not damage other cell. So we have already used the neurotransmitters in the terahertz devices that can be diagnosis of the teeth in early stage. And in this project, there are 2 students, they are already worked for the programming to make how to know the young people teeth child teeth and older people teeth. They can also measure it by the devices. And that is the computational, mathematical. This is our results in different terahertz. In industry application, if you want to the pattern like chip, there have some in semiconductor industry, there are different chip. If you want to find the problem in chip, our microscope can do it. Look the results. There are two images. Upside image is our microscope, and down side is a SCM. SCM is a scanning electron microscope. It's very expensive. And our microscope, if you compare the results, it's not more difference. It's very close. So it means our microscope resolution is 50 nanometer. 50 nanometer. In the natural, all the microscope, optical microscope in visible light is the resolution commonly 532 nanometer. But we have achieved the 50 nanometer resolution by improving the concept in the polarization. So that ideas have been published in the high level SCI, the impact factor at 21 point something. So it's very good ideas there. It's like if you want to measure in different angles, you can find a result by polarization. One of the students has finished his PhD under this topics. Now he is working in USA. He has done PhD last 5 years before. His PhD was very nice, and he have done very good thing. His result is there. It's FTDT. Maybe most of the students heard this name, FTDT, and our microscope TME, and this is the conventional. It means the is ordinary image there, and our image is TME. If you look the image of TME, it's very close to that. And he claimed this result to that paper. That paper, it's only 2 days. It will take only 2 days, and impact factor is 21 point something. And they suddenly accept the paper. Because papers is only this thing is very new. He also done the AFM. AFM, and there are conventional. We find that defect is very close. Chemical project. This is the concept. We are applying this concept to making the fabrication of the terahertz. Now the conclusion. The future of terahertz technology holds great promise across various fields. Advancement in miniaturization and portability will make terahertz device more compact and portable, allowing for practical application in healthcare, security, and industrial inspection. Increasing power output and efficiency will enhance imaging, communication, and sensing capability, driving the adoption of terahertz technology in diverse industries. Moreover, the integration of terahertz technology with existing systems such as smartphones and IoT infrastructure will enable real-time monitoring and diagnosis. The simulated structure is able to produce core confined mode up to 2.25 terahertz. The thickness were optimized, and hence the structure possesses minimal fabrication compatibility. The waveguide can be used for the terahertz applications such as probe for terahertz sensing and imaging. The structure can be simulated with different set of interface layers to further reduce the loss. The opening bandwidth can be improved by adding more interface layers. In future, the structure will be fabricated and characterized by obtaining other losses such as scattering loss, dispersion, and coupling loss using terahertz time domain spectroscopy. Quantum enhanced terahertz technology, novel application, autonomous vehicle, and advanced manufacturing and utilization of advanced data analysis and artificial intelligence or other exacting except that will be shape the future of the terahertz technology. Collaborative research and development efforts will play a crucial role in driving innovation and realizing the full potential of this transformative technology. Terahertz instrumentation has improved significantly in recent years such that terahertz imaging systems have become more affordable and easier to use. Terahertz system can now be operated by non-terahertz experts, generally facilitating research into many potential applications due to the non-energizing nature of the terahertz light and its high sensitivity to soft tissue. There is an increasing interest in biological application, including both in vivo and ex vivo studies. Additionally, research continues to understanding the origin of constructs and how the interpret terahertz biomedical images. Now, recently I got this project is international young scientist by using the gold nanocluster for cancer treatment. Gold nanocluster I used by neurotransmitter in the terahertz device. Based on this idea, the Chinese government given me the International Young Scientists Research Fund is about 4 crores Indian currency. In this project, have the very good option to offer the Indian students who are doing PhD from IIT, basically from IIT, not the private university. NIT is also okay. NITs and IITs who are doing the PhD, who want to do the in terahertz research, they are welcome to my group for 6 months and 3 months. You can choose based on your based on your requirement. You can come here to work 3 months or 6 months, and we can provide everything like hostels. We can provide 1 rooms for you, and we can give some scholarship. And additionally, if you publish some SCI papers, we can give some research funds. And one time from India to China, China to India, we can give some flight tickets. So it's a very good option for the Indian students. If you want to really the good research, it means if you come to China, you must publish SCI in 3 months or 6 months. Then it is okay. If you not publish SCI, it's not like India. China is very strict. It means they can cut your money. They can cut your research fellowship. Okay, so they can only give you the flight money, like from India to China, China to India. So the publication is not more difficult because I am there. I will be helped. So only you have to follow my suggestion. You can do the publish. It's no problem. There are some questions and some suggestions there. I start my research, my supervisor, basically my ideas come from the IIT BHU. Maybe some people from here know the Professor B. R. Vishkarma. He is very old now. I meet him 2 years before. I take the picture with him. He given me the good ideas in microstrip patch antenna. Nowadays, I am this position with help of him. That's why I show him his picture now here, because I like too much to him. He given me a lot of good ideas in the ground ideas. And after that, you know that they have 2 people. One from India. He was the vice chancellor from the is a BBS University in Jaunpur. Professor Raja Ram Yadav, he was the vice chancellor there, and I invited to him in China, in Nanjing University, to give some lectures. At that time, he went in China, and one other people, he is my postdoc supervisor. I finished my postdoc under him. He's a Liu Shufeng, is a Chinese name. So both are now is very good friends, and they are working in the collaborative research project. And one picture there have three people is collaborative research team. One professor from Richardson, he is from Glasgow University, USA, and one lady from Russia, he is working the terahertz camera, and one other from your teacher asking about that university, Tsinghua University in China. He is a collaborative research team member, and one woman, he is from Shanghai Jiaotang University. So all the four members, they are very good research collaborative team members there. And there I have one picture. We are doing the dinner. Is my PhD students. They are one of the Russian students, two from the China, one from the Russia. Recently, there I have supervised three PhD students, two students from China, one from Russia, and in the back they have the master MTech students. They are doing the masters under guidance me, and one time they just asked me to give some speak something about the India. So that time I given some concept about the Indian concept, how the working the Indian student there. So this is all the memories of my how I grow in my research. They are help me a lot. All the person, they are very useful in my life. The PhD students, they are always helping to me. Even if I face some problem in China, they are always ready to help me. The two students, PhD students, they are very good. And now they have mostly in 6 months or 3 months, they publish at least one SCI high level. They are very, it's like on the time. If I ask, you must go to the lab, you have to finish this work, they will do it. And sometime in the night time, they work whole night in the lab. So this is some memories. And the last, I want to ask some people, some students, if you want some question, belongs to China, India, terahertz, or something about science, you are welcome to ask me question. I am not only the electronics communication, I know all the majors. Okay, so you can ask any question about other major also. I can help you. Okay, thank you.
Queries from the participants in chat box. Yes. Sir, thank you very much. In the chat box, participants have appreciated the lecture and they have said very nice session. Sir, one of the participants, Jaswinder Kaur, has said that they are working in the area of microstrip patch antenna design from past 15 years and they want to collaborate with us. Sir,
if you want to work in the microstrip patch antenna design, is very good. You have to do the collaboration work. There are some options. You have to choose the major. You have to choose the waveguide antenna. That will be very useful. Or if you use some like a array antenna design, is also very useful. So you are welcome. It's no problem. You can do the collaboration.
Any more questions are there? Please ask. This is a request to all the online participants as well. Sir, one question from participant Mahesh Pengre that is it possible to manufacture and test terahertz antenna in India, and what is the range up to which it is?
In India, basically, the ISRO Ahmedabad and ISRO Bangalore, they are working on the terahertz device. They are able to implement and they have already successfully made the device. It's especially range should be 0.1 to 10 terahertz, it will be acceptable nowadays.
Participant Raghav Trivedi has asked, please give a glimpse of how to do a postdoc under your guidance.
Once more.
How to do a postdoc under your guidance.
Postdoc is very simple. You have to finish your PhD program in India. If you're doing the PhD program in Indian Institute of Technology, especially IIT Mumbai, IIT Delhi, or any IIT, even NITs, that will be very easy to got the postdoc position under me, because the 50% under me, but 50% based on the government policy. The new government policy, it should be age should be 35 years, and the Indian students should be from belongs to the NIT or IIT. And when you finish your PhD, you have to complete your PhD certificates, mean final degree, and you have to be your passport. Two things should be ready. Then I will help to apply the postdoc position under guidance with me.
Next question is, how to get various substrates from China, like polyamide or any other substrate to India? Also, how can you and your group can help in this regard?
If you need the polyamide
Polyamide substrate.
yeah, is substrate is no problem. There have nowadays a lot of facilities is possible to from China to India, India to China. I just come back in India. I am collecting 18 sample, and when I back to China, I will do the experiment there. So it's not the problem to substrate or any sample to from China to India, India to China. There are some procedure. Just you have to fill some application, and when the custom officer asks to you, you have to show them. It's no problem. It's very easy. Especially for academic, it's no problem.
A participant Rahul Porwal sir has asked, and Uday Kumar sir, that is it possible to help to design implantable antenna for medical applications?
Yeah, is antenna, any type of antenna, you can design it. But you have to, before design, you have to think about application, where you to apply in medical science. So in the antennas, you can design the microwave antenna, is like wearable antennas. Wearable antennas can be useful in cancer detection. If you want to like human other disease detection, you have to go to the terahertz antenna. So terahertz antenna and microwave antenna, both antenna can be useful in a medical science. But before you start designing, you have to fix your application target. That can be more easy.
Afrin Khan, she has again asked that how to join the postdoc under your guidance. Afrin, she has also completed the PhD from Jamia University. So if Afrin, is her doubt clear from this sir, or sir has to repeat it again?
Jamia University, I am sorry to say that because I don't know more about the Jamia University, because the new policy comes from the Chinese government. It should be from IITs or NITs, but it's not the accurate rules. If Jamia University also okay, but based on the student qualities, if he have or she have published some good SCI in MTech level or PhD level, it should be possible. It's based on my our collaborative interview times. It's not the big problem, but the most chances is IITs and NITs students, they are acceptable very quick. No any problem.
Next question. How can we design flexible PCBs along with sensors soldered to it for wound health monitoring as the participant want to design small bandages?
Yeah, this
Sir?
Yeah, this is a very good question. The flexible. Nowadays, a lot of materials is coming in the industry, coming the research. So, if you want to design the flexible, you have to choose the good materials which can be useful in flexible, and you can design it. It's no problem. It can be designed.
That's it, sir. No more questions. Thank you very much, sir, for the lecture, and it was very, very much knowledgeable. Thank you for motivating us, and I hope that everybody has received the solutions for whatever queries you have. Thank you very much, sir.
Okay, thank you. Here, if you want to any student, you are welcome. Rest of time you can connect with the doctor, and he will. If you want to by email or something, you can go to the first page. You can directly email to me. You can directly email to me my official email. Basically, I using these two official email.
A few participants have asked for LinkedIn profile.
LinkedIn profile, basically, I am not using more. In China, they have using the WeChat. So my profile basically in WeChat. I can give you the LinkedIn later, but I not updated anything in LinkedIn. In LinkedIn, only I write my all the information, but related my new ideas, new discovery in research group, I not sharing there. But in my Chinese website, in the WeChat, like here WhatsApp there, but there have the WeChat. I already updated everything there. The most of the research papers in the Scholars-1. Scholars-1 is the Chinese one website. It's like here ResearchGate. In ResearchGate, I have already updated many papers, but all the papers I cannot upload because due to the VPN policies. There have some security. You cannot use the Google. You cannot use the Gmail. So we upload all the papers in Scholars-1 at the Chinese website. But if you want any queries, if you're interested to do the research, if you want to come there, you can connect with him directly. Okay. If you write email to me, is also okay. No problem. Recently, in during my visit, I already given the offer, young students, and maybe one student, they can come to my research team and they can do the postdoc. Okay. And I will help you to get future. It's no problem. There are many Indian teachers and students there, but you have to target concept. You have to fix your target. We will stay in China, okay? Not back to other countries. Because if you join to my team, there have some policy. Before joining the team, you have to sign there. At least 2 years, you have to work in my research team, because maybe 2 years, there have some hard work. We will give some good task. During that task, most of the students, they afraid. They want back to India. They just remember as parents. So you have to forget everything. And in the 2 years, if you pass the 2 years, you feel very happy. You enjoy every time. Your life will be grow up. So I given to concept, you have to start the web guide something, and skill, console, aptitude, CST, you can learn everything. Because there are two tasks, SCI paper and project writing. Always the postdoc student, they working only two things, no any teaching. You have to focus on SCI paper and you have to write the project proposal. And supervisor always check your progress. I will be the supervisor. Okay, so it's not problem because we are Indian. We know each other. So it will be good, very good for you. If you any personal problem or any family problem, you can share to me. We will help them. And details about if you want to start the work now, I will discuss maybe today or tomorrow. There are some rules. If you follow the rules, now you can start the work. We will give some fund online.
Yes, it should be.
Okay.
Participants, next session will be hands-on session and will begin from 4 to 6. Therefore, we all request you to kindly join by 3:45 p.m. Thank you. In continuation to this, if any queries are there,